Welcome to AtlasExplore, a sanctuary where science meets stillness, wonder, and the quiet pulse of the cosmos. Tonight, we drift beyond the borders of what is known, into the gentle twilight of mystery where questions still echo. Science, in its most human form, is not a book of final truths, but an unfinished symphony. Every mystery, a note in the music of curiosity. Let your mind open like a night sky, and let each unknown become a star. On this journey, we'll wander through 100 things science has yet to explain, not to chase answers, but to rest in the beauty of not knowing, and to remember that mystery itself can be healing. The universe is vast, quiet, and full of questions that still shimmer beyond our reach. No one truly knows why there is something instead of nothing. The questions sound simple, almost childlike, and yet it is the deepest one we can ask. Why should reality exist at all? Physics can describe what happens once existence begins, how galaxies form, how stars burn, how light bends, but it cannot explain why there is a canvas upon which any of it could unfold. Some physicists imagine that even nothingness is unstable, that the void trembles with restless potential, birthing fleeting particles that flicker into being and vanish again. Perhaps our universe was born from that same silent pulse, a spark of inevitability in an infinite sea of possibility. Others dream of countless universes, each one with its own rules, bubbling into existence like foam on the surface of eternity. But even that only moves the mystery one layer deeper. Why should anything, even the multiverse itself, exist? Philosophers whisper that maybe existence is simply the natural state, and non-existence is impossible. Perhaps reality must be, in some form, forever. And so we stand here, in a universe vast beyond comprehension, aware enough to wonder why it is here at all. Every atom, every star, every breath is built upon that one unanswered question. Why something, and not nothing? We can trace the story of the cosmos back almost 14 billion years to a time when everything that exists was compressed into a single, blinding point of light. We call that beginning the Big Bang, the first dawn of space and time. But what lit that spark? What caused the universe to begin? Cosmologists can map the early universe in exquisite detail, tracing it back to a fraction of a second after its birth. They tell us that in that first instant, the universe expanded faster than light, in a sudden swelling called inflation. But what triggered inflation? Why did it start, and why did it end? Some theories picture a quantum fluctuation, a tremor in the fabric of reality that gave rise to the entire cosmos. Others imagine a cycle without beginning or end, where universes expand, collapse, and begin again, like cosmic breaths. The mystery deepens because if the Big Bang includes the birth of time itself, then asking what came before may not even make sense. Our finest instruments, the Hubble Space Telescope, the Planck satellite, the James Webb, can peer back to the universe's infancy, but none can see into that first instant. The true beginning remains hidden, a secret folded into the darkness before time. Every moment flows in one direction. The present slides into the past, and never the reverse. A broken glass will not leap back together. Spilled coffee will not return to its cup. This one-way motion, the arrow of time, defines our entire experience of reality. And yet, when physicists look at the fundamental laws of nature, they find no reason why time must flow forward. The equations work just as well in reverse. So why does time move only one way? Scientists often connect the arrow of time to entropy, the gradual drift from order toward disorder. The universe began in a remarkably ordered state and has been running down ever since, energy spreading and structures dissolving. But why did it begin that way? What set the initial conditions so precisely that time could even have a direction? Some physicists think the arrow of time might emerge from the way information spreads, or from the cosmic expansion itself, as if time is the universe stretching, breathing outward. Yet none of these answers are complete. We live inside this current, carried forward by a mystery so intimate that it touches every heartbeat and every falling leaf. When astronomers study the motion of galaxies, they find something strange. The stars at the edges spin far too quickly, as if held in place by invisible hands. By all known laws, they should have drifted away into space long ago. Instead, they remain bound together, orbiting around something unseen. The only explanation is that most of the universe's mass is not visible. We call this hidden substance dark matter. It neither glows nor blocks light. Telescopes cannot see it directly, and yet its gravity sculpts everything. It holds galaxies together, bends starlight from distant clusters, and weaves the vast cosmic web that spans the universe. Scientists have searched for decades to find its true nature. Some believe it consists of undiscovered particles, perhaps ghostly WIMPs or axions that barely interact with ordinary matter. Others suggest dark matter could be a population of ancient black holes formed in the first seconds after the Big Bang. Experiments buried deep underground wait for a single collision, a whisper of dark matter brushing against ordinary atoms. But so far, nothing has been heard. For now, this invisible mass remains one of the universe's greatest secrets. Silent, unseen, and everywhere. If dark matter binds the cosmos together, dark energy is what drives it apart. In the late 20th century, astronomers expected to find that gravity was slowing the expansion of the universe. After all, everything pulls on everything else. The cosmic explosion should gradually be losing its momentum. Instead, they discovered the opposite. The universe is not slowing down, it is speeding up. Galaxies are racing away from each other faster and faster, as if space itself were expanding from within. This invisible force, this strange pressure woven into the fabric of reality, is called dark energy. It makes up almost 70% of everything that exists, yet we know almost nothing about it. Some believe it is the energy of the vacuum itself, the quiet hum of nothingness. Others imagine a dynamic field that changes over time, or a sign that our understanding of gravity is incomplete. Whatever it is, dark energy will decide the universe's fate. If it remains constant, galaxies will drift endlessly apart until even starlight fades and the cosmos falls into darkness. If it grows stronger, it could one day rip apart galaxies, stars, and even the atoms within us. We can measure its effect, but not its essence. Dark energy is the unseen hand that shapes the ultimate destiny of all things. The laws of physics seem perfectly tuned for life. Change the strength of gravity or the electromagnetic force by the tiniest fraction, and the universe would collapse or never form at all. Stars would not shine. Atoms would not hold together, and there would be no chemistry, no life, no us. This delicate balance is called fine-tuning. Why should the cosmos be so precisely arranged? Some say it's coincidence, a cosmic accident that happened to fall within the narrow window that allows life to exist. Others believe that countless universes exist, each with different laws, and we simply inhabit one where the conditions are right. Still others suggest there is a deeper principle, a rule of nature that forces the constants to take these values, as if the universe had no choice but to allow itself to be observed, whatever the truth. The fine-tuning of the cosmos fills many with awe. It hints that our universe, against all odds, seems not random but remarkably poised, balanced on the edge of possibility. No one knows how large the universe truly is. The part we can see, the observable universe, stretches about 90 billion light-years across. But beyond that horizon lies a realm we can never reach. Light has only had so much time to travel since the Big Bang, and so there is an edge to our vision, a cosmic boundary not of space, but of time. Beyond it, we do not know what lies. Some believe the universe is infinite, stretching endlessly in every direction. Others think it is finite but unbounded, like the surface of a sphere. Travel far enough in one direction, and you might eventually return to where you began. Astronomers search for clues in the cosmic microwave background, the faint afterglow of the Big Bang. Its subtle patterns might reveal whether space curves or lies flat. So far, it appears nearly flat, though this does not settle the question of whether it is infinite. Perhaps the universe loops back on itself, or perhaps it stretches forever. Either way, the true size and shape of the cosmos remain hidden just beyond our reach. Beyond that horizon, past the limits of what we can see, reality continues. The most distant galaxies we observe are sending us light that has traveled for over 13 billion years. But beyond them lies the unobservable universe, a region forever beyond our instruments. It is not a physical wall, but a limit set by time and light. What exists beyond? Perhaps endless galaxies, perhaps realms with different physics altogether. Some theories of cosmic inflation suggest that our visible universe is just one bubble in a much larger multiverse, an infinite ocean of expanding realities. If true, the vast majority of the universe lies beyond what we can ever know. We are bound to a single cosmic island, surrounded by oceans of mystery. The night sky, magnificent as it is, shows us only the faintest glimpse of the whole. The multiverse, the idea that our universe is only one among many, stretches imagination to its limits. In some theories, each universe forms like a bubble in a vast cosmic foam, with its own laws and constants, its own beginnings and endings. In others, the equations of string theory allow a near infinite number of possible worlds, each representing a different solution to the same underlying mathematics. If this grand ensemble of universes is real, it might even explain why ours appears so perfectly tuned for life. We exist in a universe suited for observers, because only such universes can be observed. Yet the multiverse is a dangerous kind of beauty. It may be forever beyond our ability to test. No light or signal can cross from one universe to another. If the multiverse is true, it may remain a matter of philosophy as much as physics. Still, the thought that reality might be infinite in scale and diversity opens the heart to wonder. Perhaps every possibility exists somewhere. Perhaps each dream, each version of what could be, is real in some distant cosmic sea. And beneath it all, beneath galaxies, gravity and light, space and time themselves may not be what they seem. Einstein showed that they are not rigid backdrops, but flexible dimensions, bending and stretching under the weight of matter. Yet at the smallest scales, quantum mechanics paints a different picture, one of jittering uncertainty, where energy and position fluctuate in a restless dance. Reconciling these two views, the smooth elegance of relativity and the granular chaos of quantum theory, is one of science's greatest challenges. Some physicists now believe that space and time are not fundamental at all, but emerge from something deeper, perhaps from networks of quantum information or entanglement. In this vision, the universe is woven from relationships rather than things, from patterns of connection that give rise to the illusion of geometry and motion. Others wonder if time itself might be an illusion, not a flowing river, but a structure created by the mind's way of perceiving change. If so, the stage on which the universe unfolds may be only a projection of a deeper, timeless reality. And perhaps that is the quietest truth of all, that beneath the fabric of stars and matter, beyond light and darkness, beyond even space and time, lies something we have not yet begun to name. The mystery that breathes through the universe is not outside of us. It moves within us, too, in our questions, our wonder, and our longing to understand. The cosmos is not just what we observe, it is what we are made of. To look into the universe is to look into ourselves, into the stillness that asks, softly and eternally, why anything exists at all. In the strange world of quantum physics, reality no longer behaves the way we expect. It softens at the edges, blurs, and becomes uncertain, a place where the solid world dissolves into waves of possibility. At the smallest scales, A single particle can exist in many states at once. An electron does not sit neatly in one place or another, but hovers in a cloud of probabilities, a mist of maybes. It can pass through two slits at the same time, interfere with itself, and create patterns that defy ordinary logic. This is called superposition, the idea that, until we observe it, a particle occupies all possible positions simultaneously. Only when measured does it choose one reality. We see a result. But before that moment, the universe itself seems undecided. Some physicists believe this dual nature is simply how the world is. Others wonder if it reflects our own limits. That superposition is not a property of particles, but of our incomplete understanding. Either way, at this microscopic scale, the universe behaves like a dream, not fixed, but fluid, not certain, but shimmering with potential. Even stranger is the phenomenon known as entanglement. When two particles interact in a certain way, they become linked forever. Their fates intertwined, no matter how far apart they drift. Measure one, and you instantly know the state of the other, even if it lies on the opposite side of the galaxy. Einstein called this spooky action at a distance because it seemed to violate the rule that nothing can travel faster than light. And yet, experiments confirm it again and again. Photons, electrons, even entire atoms sharing an invisible connection. There is no signal between them, no hidden wire or pulse. It is as if the universe itself keeps a quiet ledger, ensuring the two always remain in step. Entanglement has become the foundation for quantum computing and cryptography, but no one can truly explain how it works. Some suggest that the entire universe is built from these invisible threads of correlation, that everything is connected at a level beyond space and time. If that is true, separation may only be an illusion, and what we call distance is just the surface of something deeply, endlessly connected. Then there is the mystery of observation, the moment when potential becomes actual. In countless experiments, particles behave like waves when unobserved, spreading out in patterns of probability. But the instant we try to measure them, the wave collapses, and the particle appears in one specific place. It is as though the act of looking changes what is being seen. This is known as the measurement problem, and it lies at the heart of quantum theory. Why should mere observation alter reality? What counts as an observer? Is it the measuring device? The consciousness behind it? Or does observation simply mark the point at which information becomes irreversible? When the universe commits to a single story. Some interpretations propose that all possibilities happen, each in its own branch of reality, creating a multiverse of outcomes. In one, the particle lands here. In another, it lands there. In this view, every act of observation splits the world endlessly. Others insist that the wave function's collapse is only apparent, a mathematical trick hiding deeper rules we do not yet understand. Whatever the truth, the quantum world seems to whisper that awareness and existence are entangled. That to observe is somehow to participate in creation itself. Even gravity, the most familiar of forces, hides a quiet strangeness. It rules the motion of planets, bends light, and sculpts the galaxies. Yet compared to the other forces of nature, it is astonishingly weak. A small magnet can lift a paperclip against the pull of the entire Earth. Why should gravity be so feeble? This imbalance, known as the hierarchy problem, has puzzled physicists for generations. Some suggest that gravity's apparent weakness is an illusion, that it spreads into hidden dimensions beyond the three we perceive, thinning as it leaks through the fabric of space. Others propose that the true scale of gravity is strong, but masked by unknown physics at microscopic levels. Whatever the reason, this gentle weakness is what makes the universe possible. If gravity were much stronger, stars would collapse too quickly, black holes would devour everything, and life could not endure. The quiet pull that holds our feet to the ground is, in its own way, a cosmic act of mercy. And so we arrive at the Great Divide, the tension between the two pillars of modern physics. Einstein's general relativity describes the vast, smooth curves of space-time, predicting the motion of planets and the dance of galaxies with perfect precision. Quantum mechanics, on the other hand, rules the tiny, turbulent world of particles, explaining the structure of atoms and the glow of light. Both are breathtakingly accurate in their domains. And yet, when we try to unite them, they refuse to fit. In the heart of a black hole, or the first moments after the Big Bang, where the enormous and the infinitesimal collide, both theories break down. Infinity piles upon infinity. The equations lose meaning. For nearly a century, physicists have searched for a bridge, a theory of everything that would weave gravity and quantum mechanics into one coherent tapestry. String theory imagines that all particles are vibrations of tiny, invisible loops. Loop quantum gravity envisions space itself as woven from discrete, spinning networks. Each idea is beautiful, but none has been proven. The dream of unification remains just out of reach, like a horizon that recedes as we approach. Perhaps, at some level, these contradictions are not flaws but invitations, reminders that reality is more mysterious than our equations can capture. The quantum world is not chaos. It is a deeper kind of order, one that resists simplification. It tells us that certainty may be an illusion, that observation and existence are intertwined, and that the universe, at its core, behaves more like a thought than a machine. The laws we know work perfectly within their boundaries, but beyond them, something else waits. Something that speaks in the language of paradox. In this space between knowledge and mystery, between gravity and uncertainty, we glimpse a truth that feels both scientific and spiritual. That to seek understanding is to walk the edge of wonder. The smallest particle and the greatest star are reflections of the same unseen rhythm, bound together by rules we only partly comprehend. And perhaps that is the real beauty of physics. Not the answers it gives, but the way it humbles us before the vast intelligence of existence itself. Deep in the fabric of space, there are places where the universe seems to fold in on itself. Regions so dense, so extreme, that the known laws of physics simply cease to work. These are black holes, the silent hearts of galaxies, where gravity grows so powerful that not even light can escape. At their center lies the greatest mystery of all, the singularity. According to Einstein's equations, everything that falls into a black hole is crushed into a single point of infinite density, where time and space collapse into something beyond definition. But infinity is not a physical number. It is a sign that our understanding breaks. Many physicists believe the singularity is not real, but rather a symbol, a boundary, showing where our theories fail. What truly exists inside a black hole may be something far stranger. A finite core of warped space, a loop of time folding back on itself, or perhaps a bridge to another region of the cosmos. We cannot see it. The event horizon, that invisible border around the hole, hides everything within. What happens inside is sealed away, leaving only gravity's whisper to reach the outside world. Yet even as we peer into that darkness, another riddle arises. The question of what happens to information when it falls beyond the horizon. In physics, information is sacred. It describes the exact state of every particle, every detail of matter and energy. According to quantum theory, information can never be destroyed. It can change form, scatter, or hide, but it must always exist somewhere. And yet, when matter crosses the boundary of a black hole, it seems to vanish completely. Does the information it carries disappear as well? If so, one of the most fundamental principles of quantum mechanics would be broken. This is the black hole information paradox, a puzzle that has haunted physics for decades. Stephen Hawking proposed that black holes are not perfectly black, that they slowly emit faint radiation, leaking energy over time. This Hawking radiation implies that black holes could eventually evaporate entirely. But if they vanish, where does the information go? Does it dissolve with them? Or does it somehow escape encoded in the radiation itself? No one knows. If information is truly lost, then quantum mechanics is incomplete. If it is preserved, it must be hidden in a way we have yet to uncover. Hawking's idea that black holes radiate energy is one of the most beautiful and daring concepts in modern science. It unites gravity, quantum theory, and thermodynamics into a single, elegant picture. According to his calculations, the intense gravity near the event horizon disturbs the vacuum of space, creating pairs of virtual particles. One particle escapes, the other falls inward, and the black hole loses a tiny fraction of its mass. Over unimaginable stretches of time, this process would cause even the largest black holes to fade away, releasing their energy back into the universe. Yet no one has ever seen this happen. The radiation is too faint, drowned out by the violent light of surrounding gas and dust. If Hawking radiation is real, it confirms that black holes are not eternal prisons, but part of the universe's great cycle of creation and decay. If it is not, then something even stranger must be taking place at the edge of space-time. Something that may force us to rewrite the laws of physics themselves. Still, the idea that a black hole might not be an end but a doorway is irresistible. Some solutions to Einstein's equations hint at the possibility of wormholes, tunnels through space-time, that could connect distant regions of the universe, or even bridge one universe to another. In this vision, what we see as the mouth of a black hole could be an entrance. And somewhere far away, another black hole could serve as the exit. Travel through such a passage would defy every limit we know, folding distances of light years into a single instant. Science fiction has long dreamed of such gateways, shortcuts through the cosmos, hidden within the darkness. In theory, wormholes could exist. The mathematics allows them. But in practice, they may be too unstable to survive. The immense gravity that forms a black hole could also tear any tunnel apart before anything could pass through. And yet, the equations refuse to close the door entirely. There remains a sliver of possibility that the universe, in its boundless creativity, has found ways to connect itself through unseen paths. The more we study black holes, the more they seem like mirrors held up to our ignorance. They compress not only matter, but meaning, the limits of what we can observe, what we can know, what we can imagine. Around them, space-time bends so deeply that even causality, the order of before and after, begins to blur. They sit at the intersection of the known and the unknowable, where quantum uncertainty meets cosmic scale. To understand them would be to understand the birth of the universe itself, for the early cosmos shared their same conditions: hot, dense, and beyond comprehension. Some physicists suspect that the Big Bang might have been a kind of reverse black hole, an explosion instead of a collapse, where time flowed outward instead of inward. In that sense, every galaxy, every star, every living thing is an echo of that first singularity. Black holes remind us that mystery is not absence but depth, that there are places where our equations fall silent, and only wonder can continue the story. They show us the humility of science, the edge where curiosity touches the infinite. We cannot peer beyond the event horizon, but we can imagine. We can listen to their gravitational songs, watch the light swirl around their edges, and know that something extraordinary lies within. Perhaps, in time, we will learn that the singularity is not a dead end, but a seed, a point where reality folds inward to bloom somewhere else. Perhaps what falls into darkness is never lost, only transformed. And so the black hole stands as both riddle and revelation, a reminder that the universe keeps its secrets not to mock us, but to invite us closer. Each unanswered question draws us deeper into the cosmos, into the same silence that beats within every heart, the pull toward the unknown, the quiet gravity of awe. Far back in time, before there were stars, before galaxies shimmered in their spiral shapes, the universe was dark and simple, a sea of hydrogen and helium, adrift in endless night. For hundreds of millions of years after the Big Bang, there were no lights in the sky, only the soft afterglow of creation fading slowly into blackness. Then, somewhere in that darkness, clouds of gas began to gather, drawn together by the quiet pull of gravity. They swirled, collapsed, and heated until, for the first time, the universe caught fire. The first stars were born, enormous, short-lived giants called population 3 stars. They burned hotter than any that came after, hundreds of times more massive than our sun, fusing hydrogen into heavier elements and seeding the cosmos with the ingredients of life. But their brilliance was brief. In only a few million years, they exploded as supernovae, scattering the first metals through space and lighting up the cosmic dawn. None of these ancient stars remain today. They lived and died long before our world existed. Yet every atom of carbon, oxygen, and iron that makes up our bodies once passed through their flames. We are the quiet echo of their light. Among the ashes of those early stars, something else emerged. Monsters of gravity that defy understanding. At the centers of galaxies, we find supermassive black holes, millions or billions of times the mass of the Sunday. They shape the motion of stars and power the brightest beacons in the universe, quasars whose light can outshine entire galaxies. But the puzzle is how these giants appeared so soon. Some are found less than 1 billion years after the Big Bang, far too early for ordinary growth. A black hole can expand by feeding on gas and merging with others, but there simply wasn't enough time. Perhaps they were born large, collapsing directly from colossal clouds of primordial gas, skipping the smaller stages entirely. Or perhaps they grew from the deaths of the first stars, massive enough to ignite a chain of feeding frenzies that built them at astonishing speed. Whatever the path, these early black holes should not exist as they do, and yet they do. Silent witnesses to a cosmic adolescence we still do not fully comprehend. When we turn our eyes to the galaxies themselves, another mystery unfolds: the grace of the spiral. The Milky Way, our home, is one among billions of galaxies that unfurl in sweeping, luminous arms. Their structure seems almost alive, spirals of stars curling outward, like the shells of ancient seas. But why do so many galaxies take this elegant form? One idea is that spiral arms are not permanent structures at all, but density waves, regions where stars slow and bunch together, like traffic gathering and dispersing on a cosmic highway. As stars move through these waves, new ones are born in their wake, keeping the pattern alive. Another idea suggests that spirals form through the gravitational dance of galaxies tugging at each other, stirring their stars into graceful swirls. Simulations can recreate these shapes, but never perfectly. For reasons we still don't understand, spirals persist across the universe, dynamic yet enduring, fragile yet eternal, like frozen whirlpools in the sea of space. And then there are the voices of the cosmos, sudden flashes of radio light that last only a heartbeat but carry the energy of an entire year of sunlight. These are the fast radio bursts, or FRBs, one of the most baffling phenomena of modern astronomy. First detected by accident in 2007, they appear without warning, scattered randomly across the sky. Some repeat, others flare only once and vanish forever. Their origins remain uncertain. Perhaps they come from magnetars, ultramagnetic neutron stars that occasionally release titanic flares. Or perhaps they are the final breaths of collapsing stars, or the collisions of black holes. Each burst travels for billions of years through cosmic space, bent and stretched by everything it passes. By studying them, astronomers can map the hidden matter between galaxies, yet the source of their voice, that single millisecond of unimaginable power, remains unknown. It is as if the universe itself speaks in brief, brilliant syllables that no one yet understands. Among the most rhythmic of cosmic voices are the pulsars, the dense, spinning remnants of exploded stars. Only about 20 kilometers wide, they rotate hundreds of times per second, sweeping beams of radiation through space like celestial lighthouses. When their beams cross Earth, we detect precise pulses, so regular that some pulsars keep time better than atomic clocks. What allows them to maintain such perfection? Their interiors are made of matter crushed beyond imagination, nuclei fused into exotic forms and wrapped in intense magnetic fields. Occasionally, these stars glitch, momentarily speeding up or slowing down, as if their deep interiors had shifted. Some scientists think the cause lies in superfluid layers within the star's core, where particles flow without friction. Others suspect crust quakes or magnetic stresses. Whatever the reason, pulsars remain among the universe's most precise yet unpredictable instruments, ticking hearts of collapsed suns, keeping time for the cosmos. Even stranger are the magnetars, a rare kind of neutron star with magnetic fields so intense that they twist space itself. A magnetar's field is 1,000 times stronger than that of an ordinary neutron star and 1,000,000,000,000 times stronger than Earth's. When these fields snap or rearrange, they release bursts of energy so fierce they can momentarily outshine the sun by 100,000 times. These eruptions are seen as flashes of X-rays and gamma rays, sometimes linked to fast radio bursts. The cause remains uncertain. Are the bursts triggered by starquakes, cracks in the crust under unbearable magnetic tension? Or are they driven by sudden reconfigurations of the magnetic field, releasing stored energy like a cosmic rubber band? We don't know. Magnetars are rare. Only a few dozen are known. Yet their power is staggering. They remind us that in the heart of collapse lies creation, and that even in death, stars can burn with unimaginable strength. Across the cosmos, high-energy particles called cosmic rays strike Earth every second. Tiny messengers from deep space. Most are protons or atomic nuclei, traveling close to the speed of light. Many come from supernovae, but some are so energetic that we have no idea where they come from or how they are accelerated. The most powerful among them carry as much energy as a fast-pitched baseball compressed into a single particle. No known process should be able to hurl matter to such extremes. Perhaps they are born in the violent hearts of active galaxies, near supermassive black holes where magnetic fields twist like storms. Perhaps they are relics of events that happened in the first moments after the Big Bang. When these particles collide with Earth's atmosphere, they create showers of secondary particles that we can detect on the ground, brief storms of invisible rain from the stars. They remind us that somewhere out there, the universe runs accelerators far greater than anything humans could build. But the universe is not all motion and light. Between the filaments of galaxies lie cosmic voids, enormous regions almost completely empty. They stretch for hundreds of millions of light years, vast spaces where only a few lonely galaxies drift in the dark. The cosmic web, as astronomers call it, is a structure of balance. Matter pulled into filaments and clusters by gravity, leaving behind immense hollows. Simulations suggest this pattern arises naturally from the growth of cosmic structure. But some voids are larger and emptier than our models predict. Do they point to new physics? Perhaps in the behavior of dark energy? Or are they simply rare coincidences? The quiet spaces between the notes of the cosmic song? No one can yet say. Looking into a cosmic void is like staring into the universe's deep breath, the pause between creation and silence. From the first sparks of light to the farthest darkness, the cosmos has always balanced birth and decay. Its future, too, is written in uncertainty. Cosmologists imagine several endings, each shaped by the nature of dark energy. In one scenario, expansion continues forever. Stars burn out, and galaxies drift apart, until only cold, empty space remains. The Big Freeze, a slow fading into silence. In another, gravity eventually halts the expansion and reverses it, pulling everything back together in a catastrophic collapse. The Big Crunch. And in the most dramatic vision, dark energy grows stronger over time, tearing apart galaxies, stars, planets, even atoms. In a final disintegration known as the Big Rip, each possibility lies billions of years ahead, yet each reminds us that creation and destruction are one continuous motion. The universe began in a flash of light and may end in a whisper. But the story between those moments is what gives it meaning, and behind even the beginning lies a deeper mystery. What caused the universe's first great expansion? The cosmic inflation that shaped everything to come. In the tiniest fraction of a second after the Big Bang, the universe is thought to have swelled faster than light, smoothing out irregularities and stretching quantum ripples into the seeds of galaxies. But what triggered that inflation? Perhaps a field of pure energy, an inflaton, briefly dominated the cosmos and then faded. Perhaps the inflation we know was only one pulse in an eternal series of births, each spawning a new universe with its own laws. We can see its fingerprints in the faint microwave glow that fills the sky, but the engine behind it remains hidden. Something, long ago, breathed fire into nothing and set the universe expanding. We still don't know what that something was, yet perhaps it is fitting that we do not. The story of the universe is not only the story of matter and motion, but of mystery itself, of how every discovery opens another door, of how creation seems to speak in questions more than answers. From the first stars to the last, from the smallest particle to the largest void, the cosmos continues to unfold like a living poem, one that we read not to reach the end, but to feel the wonder of every line. Life began as silence, a slow stirring in the ancient dark, when Earth was still young and the air held no breath. For billions of years after the planet formed, its oceans were empty of thought, its continents barren stone. Then, somewhere in that stillness, chemistry awakened. Molecules collided, linked, and broke apart, again and again, until something strange happened. A pattern began to copy itself. From the lifeless swirl of matter arose the first whisper of life. We call this abiogenesis, the birth of the living from the non-living. We know it happened, for here we are, yet we do not know how. Perhaps it began in the deep oceans, near hydrothermal vents that released heat and minerals into the water. There, the clash of temperature and chemistry could have formed complex molecules, chains capable of storing information. Or perhaps life began in shallow pools on land, where cycles of drying and rain concentrated simple compounds, pressing them together under sunlight until something stable emerged. Each theory glows with possibility, but none are complete. The origin of life is not a single spark, but a dawn hidden in time, when Earth first began to dream. Whether life first stirred in the ocean or upon land, both worlds offered what it needed: energy, water, and time. In the depths of the sea, hydrothermal vents still glow, forming natural chimneys of rock where minerals and hot water mix. Inside their hollow walls, tiny compartments mimic the boundaries of cells, creating safe havens for fragile chemistry. On the surface, the sun painted the land with light, its ultraviolet rays driving reactions that darkness could not. In small ponds, simple molecules may have joined to form chains that could store and transmit information, the ancestors of RNA and later DNA. The ocean gave stability and protection. The land offered variety and change. Perhaps life flickered in both realms before one pathway triumphed. The truth may never be known. What matters is that somewhere between sea foam and sunlight, matter began to organize itself into memory. But life is not just chemistry, it is structure. A living cell is a universe in miniature, a membrane enclosing the chaos, a space where reactions can happen in harmony. How did the first cell arise from lifeless molecules? One idea suggests that fatty acids, common in the early Earth, naturally formed bubbles that trapped useful chemistry inside. These primitive membranes could exchange matter and energy with their surroundings, yet protect their fragile contents from the outside. Within these tiny worlds, molecules could combine and grow more complex, until, at last, one began to replicate itself. Another theory points to clay minerals, whose surfaces may have helped molecules arrange themselves into patterns, teaching matter how to hold information. Experiments have shown that simple membranes and self-copying chains can form spontaneously under the right conditions. But the leap from those simple beginnings to a true, self-sustaining cell remains a mystery. Somewhere between chaos and order, between matter and mind, life learned how to persist. Every living thing on Earth, from the smallest microbe to the largest whale, carries within it a single, beautiful molecule: DNA. It is the language of existence, the thread that connects all creatures across time. Two intertwined strands spiral together in a double helix, encoding the instructions for building and sustaining life. But why this particular structure? Chemistry offers many possible ways to store information, yet DNA alone became the universal code. Its design, stable yet flexible, simple yet profound, seems almost inevitable, as though nature itself preferred elegance. Its paired bases fit together like puzzle pieces, ensuring faithful replication. Its shape allows immense information to coil within the smallest space. Still, we do not know why this form, among all possibilities, was chosen. Was it pure chance, or a necessity written into the physics of molecules? Perhaps DNA is not just efficient, but inevitable. The most graceful solution the universe could find for the problem of memory. Viruses sit on the edge of that memory, blurring the line between living and non-living. They are not truly alive. They cannot eat, grow, or reproduce on their own. Yet, they are not entirely dead either. They contain genetic material, evolve, and influence every form of life on Earth. Where did they come from? Some scientists believe viruses are ancient remnants of the RNA world that existed before DNA in cells, fragments of a more primitive form of life that survived by parasitizing its descendants. Others think viruses began as bits of DNA or RNA that escaped from cells and learned to copy themselves, evolving into independent invaders. Another possibility is that they were once full organisms, stripped down over time to their simplest form. Whatever their origin, viruses are unimaginably old. They shape evolution by transferring genes between species, driving change through conflict and adaptation. Without them, life might never have reached its present complexity. The smallest things, it seems, have always guided the greatest. Still, one question lingers at the heart of biology. Why did some molecules become alive while countless others did not? Early Earth was a vast chemical playground, filled with potential. Simple compounds formed spontaneously under lightning, heat, and ultraviolet light. Amino acids, sugars, and nucleotides accumulated by the billions. Yet only a few combinations crossed the boundary into self-replication and metabolism. Why those, and not others? Was life inevitable once the right ingredients gathered? Or was it an almost impossible accident? Experiments suggest that many of the building blocks of life arise naturally, even in space. But turning chemistry into biology, transforming inert molecules into a self-aware system, remains one of science's greatest mysteries. If life is inevitable, then the universe should be full of it. If it was a rare accident, we may be utterly alone. The truth lies hidden in that first moment of awakening, when matter first recognized itself. For now, Earth remains the only known home of life. Yet the cosmos is vast, and its conditions are fertile with possibility. We have discovered thousands of planets orbiting distant stars, many lying in the habitable zone where liquid water might flow. We have seen evidence of organic molecules on comets and moons, and frozen oceans beneath the ice of Europa and Enceladus. Mars once held rivers and lakes. Titan rains liquid methane. If life could arise here, why not there? And yet, despite decades of searching, we have found no clear sign of even a single alien microbe. No fossils in Martian rock, no signals from the stars. The silence is profound. Perhaps life is common but fleeting, or hidden beneath ice and stone where our tools cannot reach. Perhaps it is rare, a delicate flame that the universe ignites only on occasion. Until we find proof, the question remains open. Are we unique, or one among countless others quietly evolving in distant light? And if life does exist elsewhere, must it resemble our own? All life on Earth shares the same foundation: carbon, water, and DNA. But the universe may have other chemistries waiting to be discovered. Some scientists imagine silicon-based organisms capable of forming long, stable chains, like carbon does. Others envision life that breathes ammonia or swims in methane seas, like those on Titan. Still others dream of entities made not of molecules but of energy or magnetic fields, patterns of information that behave like minds. Perhaps even plasma or radiation could carry the spark of self-organization. Our imaginations may be limited by what we know. Our definitions of life may be far too narrow. The cosmos may teem with forms of existence so different from ours that we would not recognize them at all. To search for life is, in a sense, to search for the limits of imagination. How common are truly habitable worlds? It is one of astronomy's most tantalizing questions. We have found planets of every kind, giant worlds of gas, icy spheres, scorched rocks close to their suns, and Earth-like planets that circle in gentle warmth. But habitability is more than distance and temperature. A planet needs atmosphere, magnetic protection, and stability over billions of years. It needs the delicate balance between energy and shelter, between chaos and calm. Some may be frozen in endless night, others stripped bare by radiation. A few may hold oceans and clouds, green continents and storms. We cannot yet say how many of these worlds exist, or how many cradle life. Each discovery brings us closer, yet the mystery remains immense. The galaxy may be full of living worlds, or ours may be the only one awake. And so we return to the oldest question of all: are we alone? For as long as humans have looked at the stars, we have wondered whether other minds look back. We listen for radio signals, watch for chemical signatures in alien atmospheres, send probes to icy moons and red deserts. But so far, the universe has answered only with silence. Not the silence of absence, perhaps, but of distance. Maybe civilizations are rare, or fragile, or fleeting. Maybe life blooms everywhere, but communication is impossible across such vast gulfs of time and space. Or perhaps we have not yet learned how to listen. The truth may be that we are one small voice in a vast chorus, unaware that the music surrounds us. Or it may be that we are the only singers, entrusted with the universe's only chance to know itself. Whatever the answer, the search itself is sacred. To wonder is to live in conversation with the cosmos, to reach outward even as we look inward. The story of life, its beginning, its diversity, its persistence, is also the story of the universe learning to see itself. From the first molecule to the first mind, from the first breath to the first question, existence has been unfolding toward awareness. Somewhere between chemistry and consciousness, the cosmos opened its eyes, and through us, it still looks back, still asks, still dreams. Within each of us lies a universe just as vast and mysterious as the one above our heads. A cosmos made not of stars and gravity, but of thoughts, dreams, memories, and emotions. It is here, in the quiet folds of the human mind, that the greatest mysteries gather, questions as deep as any black hole, as delicate as starlight. We can map galaxies and split atoms, but when we look inward, into the source of awareness itself, We find only reflection, light chasing light. Consciousness begins where explanation ends. Every sensation, every thought, every flicker of awareness rises from the brain, billions of neurons firing in electric harmony. Yet no equation can describe what it feels like to be alive. Science can trace the signals of vision and hearing, can measure the patterns that correspond to thought. But none of this explains why there is an inner world at all. Why should matter, organized in this way, give rise to experience, to color, music, love, or sorrow? This question, the mystery of consciousness, is among the oldest and deepest in existence. Some believe awareness emerges when information flows through the brain in specific patterns, a spark born from complexity itself. Others think consciousness is not produced by the brain but revealed through it, as if matter were a mirror reflecting something fundamental in the fabric of reality. Perhaps awareness is not an accident, but a property of the universe, as intrinsic as space, time, or energy. If so, then every atom carries a faint echo of experience, waiting to awaken in forms like ours. And when that awareness turns inward during sleep, it becomes something else entirely, a theater of shifting light called dreams. Each night, our minds conjure worlds that vanish at dawn, cities we've never seen, faces we half remember, moments of joy and fear that feel utterly real. Why do we dream? Some scientists suggest that dreaming is the brain's way of sorting memory, replaying fragments of experience to strengthen what matters and release what does not. Others think dreams help us process emotion, allowing us to relive what hurts or delights in a space safe from consequence. There are those who see them as the mind's creative rehearsal, a place where ideas combine freely, where imagination runs without the gravity of reason. Yet no single theory explains their depth. Sometimes dreams echo our waking lives. Sometimes they seem to belong to another world entirely, full of symbols that feel ancient and personal. Whatever their purpose, they remind us that within us exists an entire universe of imagery, one that renews itself every night, invisible yet essential. Time, in dreams and in waking life, flows strangely through the mind. A single minute of danger can feel eternal, while years can disappear in what feels like a breath. Physics tells us that time is steady, but our experience of it is elastic. What makes it stretch or collapse? Neuroscientists suggest that the brain measures time not by clocks but by events, the number of changes it perceives. When life is filled with novelty, our minds record more detail, and time feels full and long. When life is routine, the days blur and time compresses. Fear can make moments expand, each heartbeat caught and examined, while joy and absorption make hours disappear. This inner distortion of time is not a flaw, but a kind of grace. It allows life to unfold not as a fixed sequence, but as a rhythm, a dance between attention and emotion. Perhaps this is why childhood feels endless, why age seems to hasten, and why memory itself bends time back upon itself, letting us live again within moments long gone. Memory, that fragile, miraculous power, is the architecture of identity. Every joy, every wound, every person we have loved is stored somewhere within the living web of the brain. But how? Memories are not tiny films filed away in a cabinet. They are patterns, constellations of activity spanning countless neurons. When we recall something, those patterns reignite and the past returns for an instant. The hippocampus acts as the index, weaving sensory fragments into coherent stories. Yet no one knows exactly how this happens, how electrical impulses become remembrance, how a smell can summon an entire childhood afternoon, or why some memories fade while others burn forever bright. Each recall reshapes the past slightly, altering the pattern before storing it again. We remember, but we also rewrite. Memory is not a recording. It is a living thing, growing and changing with us. In that way, who we are is not fixed. It is a story being told and retold, each time a little different, each time a little more our own. From memory arises emotion, the pulse of meaning that gives color to existence. Fear sharpens the senses. Love softens them. Anger fuels action. Sorrow slows the heart. But where do emotions come from? Some are ancient, etched deep into the nervous system. Survival signals evolved long before language. Others are subtle, shaped by culture, experience, and imagination. The body and the mind dance together in feeling. The heart races, the stomach tightens, tears form, muscles release. Neuroscientists trace emotions to circuits in the brain, the amygdala for fear, the insula for disgust, the prefrontal cortex for control. Yet these regions tell only part of the story. Emotion is not confined to the brain. It flows through the body, carried by hormones and breath, by heartbeat and posture. And beyond biology, emotion connects us to one another. A smile, a sigh, a tremor in the voice. These are the bridges between minds. To feel is to be alive. To share feeling is to belong. From emotion springs creativity, that spark of something new that seems to appear from nowhere. An artist faces a blank canvas, a poet an empty page, a scientist an unanswered question. Then, suddenly, the idea arrives, vivid, complete, like lightning from a clear sky. Where does it come from? The brain recombines old ideas in new ways, guided by intuition rather than logic. Some call it the subconscious, quietly working in the background while we rest. Others see it as a kind of conversation between order and chaos. The mind letting go of control so that something larger can speak through it. Creativity, in all its forms, feels like discovery as much as invention. When the painter sees the image before painting it, or the physicist glimpses a pattern before proving it, it feels as though they have tuned into something that already exists, waiting to be seen. Perhaps creativity is the universe thinking through us, shaping itself in color, word, and sound. At times, the mind reveals its strangeness in brief, uncanny flashes, moments of déjà vu, when the present feels impossibly familiar. You walk into a room you've never seen before and suddenly know what will happen next. The brain misfires, perhaps, triggering the feeling of recognition without a true memory behind it. Or perhaps two processes of perception run out of sync, one slightly delayed, one immediate, and the second feels like a repeat. Something déjà vu arises when a current scene resembles a forgotten fragment of the past, tricking the mind into recognition. Whatever the cause, the effect is eerie. Reality doubling upon itself, the sense that time has folded and you are watching the present replay in real time. For a heartbeat, you stand between now and then, between knowing and mystery. A glimpse, perhaps, of how fragile perception really is. The mind's influence reaches even into the body's deepest workings, as shown by the placebo effect. A patient takes a sugar pill, believing it will ease their pain, and it does. Their brain releases natural chemicals that soothe, heal, and calm, all triggered by expectation alone. The ritual of treatment, the trust, the gesture, the belief, activates hidden systems of repair. Placebos can reduce pain, lift mood, and even alter measurable symptoms of disease. They blur the line between mind and matter, revealing that thought and chemistry are two sides of one fabric. What we believe can shape what we feel, and what we feel can reshape our bodies. Yet even this miracle has limits and mysteries. Why do some people respond to placebos while others do not? Why can knowledge of the placebo sometimes fail to stop its effect? Perhaps belief is itself a form of energy, not mystical, but biological. a signal from the mind that tells the body, heal. And still, every night, we surrender to another mystery, sleep. We close our eyes, lose consciousness, and drift into a state that claims a third of our lives. Why must every creature do this? Even when it makes them vulnerable, sleep seems to repair, to renew, to weave the fragments of memory into meaning. During deep sleep, the brain clears waste and restores balance. During REM sleep, it replays experience, sculpting, learning, and emotion. Yet no single theory captures the full purpose of sleep. Some animals rest only half their brains at a time. Others need barely any at all. We know only that without sleep, the mind fractures and the body fails. Sleep is both death's cousin and life's guardian, a nightly surrender that restores the ability to awaken. But even waking cannot protect us from the slow tide of time within the body. Aging. Every living thing carries within it the seed of its own decay. Cells divide, and with each division, the protective caps on chromosomes, telomeres, shorten until the cell can no longer replicate. Damage from oxygen, radiation, and random error accumulates like rust on metal. Proteins misfold. DNA falters. Yet aging is not universal. Some creatures age barely at all. Certain turtles live for centuries. Jellyfish revert to youth after maturity. The naked mole rat resists disease and decline far beyond expectation. Why do humans age the way we do? Why do our cells follow a script that ends in frailty? Some scientists think aging is an evolutionary trade, a cost paid for reproduction and growth. Others believe it is a solvable problem, that by understanding the biology of resilience, we might one day extend life far beyond its current bounds. The longest human life confirmed lasted 122 years. But the true limit may lie farther still, waiting to be reached. And yet, even as we seek to lengthen our days, part of us knows that mortality is essential. Without endings, beginnings lose meaning. The awareness of death sharpens the experience of living. To know that time is finite is to learn gratitude for the moment. Aging, in its quiet wisdom, teaches acceptance, that change is not loss, but transformation. Perhaps life's final mystery is not how to escape impermanence, but how to live deeply within it. How to see, even in decline, the continuation of creation. The mind, in all its brilliance and fragility, is both observer and participant in the cosmic story. Through consciousness, the universe becomes aware of itself. Through dreams, it explores possibility. Through memory, it preserves its own history. Through emotion and creativity, it learns to love what it has made. We are not separate from the cosmos. We are its most intricate expression. Stardust that has learned to imagine stars. Matter that has become aware enough to ask why it exists. And perhaps that is the most profound truth of all, that the same mystery that shaped the galaxies also beats quietly within our skulls. The human mind is the cosmos folded inward, infinity looking back at itself, wondering, feeling, and forever dreaming. Life on Earth holds its own galaxies of wonder, universes of adaptation, and quiet miracles that unfold not in distant stars, but in forests, oceans, and even in the smallest cells. Every creature carries within it secrets that seem to bend the rules of what is possible. They remind us that the natural world is not fixed, but endlessly inventive. A living laboratory where evolution experiments with resilience, transformation, and grace. In some corners of that laboratory, life has learned a trick that borders on magic, regeneration. The salamander, when it loses a limb, grows another. The starfish, when torn apart, reforms itself from a single arm. Even certain flatworms can rebuild an entire body from a fragment no larger than a grain of sand. These creatures possess cells that seem to remember not only what was lost, but how to become whole again. Humans, by contrast, can heal wounds, but not recreate what is gone. A fingertip might regrow in a child, but a hand, a heart, a spine, never. Why them and not us? Scientists have discovered that in regenerating species, cells near the wound revert to an embryonic state, unlocking genetic programs that adult human cells have long since silenced. We share many of the same genes, but our bodies have forgotten how to use them. Somewhere in our DNA lies the potential for renewal, a biological song we no longer know how to sing. If we could relearn it, medicine might transform forever. Damaged hearts could heal, spinal cords could mend, lives could begin again. Some creatures, however, don't need to renew what time barely touches. Scattered across the oceans and ice, there exist beings that live for centuries, quiet keepers of time. The Greenland shark drifts beneath Arctic waters, its pulse slow, its eyes cloudy with age, living more than 400 years. The bowhead whale sings through frozen seas for over 2 centuries, its skin thick with scars from harpoons older than our nations. Certain giant tortoises pass their 200th birthday, moving with unhurried patience, as if time itself respects their pace. Even tiny clams have been found alive after 5 centuries, buried in sand. Why do they endure while others fade so quickly? The answers lie partly in chemistry, in proteins that resist damage, DNA repair systems that never rest, metabolisms that burn like embers instead of flame. Yet no single key unlocks their longevity. Each species holds its own secret rhythm of survival. They remind us that life does not move to one tempo, that slowness can be its own form of strength. Then there are creatures that defy even death's cold touch. When winter freezes the forests of North America, the wood frog succumbs completely. Its heart stops, its blood crystallizes, its body becomes a sculpture of ice. Months later, as the snow melts, the frog thaws and hops away, alive again. Certain insects and fish share this miracle, producing antifreeze molecules that protect their cells from shattering. And then there are the tardigrades, tiny water bears, nearly indestructible, able to survive not only freezing, but boiling, radiation, and even the vacuum of space. They dry themselves into a crystalline shell, suspending life until conditions improve. The mechanisms behind these abilities are still partly unknown. Some species flood their tissues with sugars that stabilize proteins. Others enter a suspended animation so profound that metabolism halts completely. If we could understand this power, the ability to pause life without destroying it, it might one day revolutionize medicine, allowing us to preserve organs for months, or place astronauts in hibernation for journeys between the stars. Among Earth's longest-lived giants, another riddle hides in plain sight. Why so little cancer? The bowhead whale has billions of cells and lives for centuries. By simple probability, it should be riddled with tumors, yet it rarely suffers from them. Elephants, too, with their massive bodies, show extraordinary resistance to cancer. This contradiction is known as Peto's paradox, the observation that size and lifespan do not predict cancer risk. In elephants, researchers have found multiple copies of a gene called P53, a guardian that detects and destroys damaged cells before they turn malignant. Whales may possess similarly powerful repair systems, though their secrets remain hidden deep in the genome. If we could uncover these defenses, they might offer new paths for human health, lessons in how nature maintains balance, even in beings as vast as mountains of flesh. The paradox of whales and elephants teaches that evolution is not careless with life. It refines protection where it is most needed, crafting resilience out of time itself. Life's intelligence does not end with healing or endurance. In the sky, migratory creatures reveal senses that border on the mystical. Birds, for instance, seem to feel the Earth's magnetic field, an invisible geometry that guides them across continents. How they do this remains uncertain. Some carry microscopic crystals of magnetite within their bodies, tiny compasses that tug at nerve endings as they align with the planet's field. Others may see the magnetic patterns themselves through special proteins in their eyes that respond to quantum effects. Whatever the mechanism, the result is extraordinary. Even when the sky is clouded and landmarks vanish, birds stay true to a direction written not in stars, but in the planet's pulse. They travel from hemisphere to hemisphere without maps or machines, guided by a force we cannot sense, but they seem born to trust. Among the most astonishing of these travelers is the monarch butterfly. Each autumn, millions of them lift into the air, leaving Canada and the northern United States to cross thousands of miles toward the mountains of central Mexico. They arrive precisely at the same forests year after year. Yet no single butterfly makes the full journey twice. The ones that return north in spring are the great-grandchildren of those that began the voyage. Somehow, this fragile creature inherits not only its pattern of wings, but its ancestral memory of direction. Scientists know that monarchs use the sun as a compass and adjust for time using an internal clock. Some evidence also suggests they sense magnetic fields, like birds do. But how do they pass this navigation from generation to generation? How does an insect that has never seen its destination find it unerringly? The answer lies somewhere between genetics, instinct, and mystery, a code written into the very air they ride. Migration, in all its forms, is a symphony of instinct. Whales traverse oceans guided by faint calls that echo for hundreds of miles. Salmon find the very stream where they were born by scenting the minerals in its water. Sea turtles crawl ashore on the same beach where they once hatched, navigating by the angle of sunlight and the pull of magnetism. Even when displaced across the globe, many species find their way home. They do not think in coordinates or maps. They feel the world as a web of invisible threads, magnetic, chemical, gravitational, and follow them with a kind of faith that defies reason. In this, migration is not just movement, but memory. The earth guiding her children through a song only they can hear. Of all these navigators, none astonishes humans more than the homing pigeon. Release one hundreds of miles away, and it will circle the sky, orient itself, and then fly straight home, through wind, rain, and cloud, across mountains and seas. Scientists have studied this talent for centuries. Some believe pigeons use the sun's position. Others suspect an acute sense of smell, mapping the landscape by scent carried on the breeze. A few think they, too, possess an inner compass sensitive to Earth's magnetic field. Yet none of these explanations fully capture the mystery. Even when released in unfamiliar lands under overcast skies, pigeons still find their way. Their ability seems to blend multiple senses into a single perception, a holistic awareness of place that humans have lost. Watching them vanish into the horizon, we glimpse a forgotten harmony between living beings and the planet itself, a connection that hums quietly beneath the noise of civilization. In every one of these mysteries, from the salamander's rebirth to the whale's longevity, from the butterfly's journey to the pigeon's return, we see a truth as profound as any in the stars, that the laws of nature are not boundaries, but invitations. Life is not a finished design, but an ever-evolving dialogue between matter and imagination. The same universe that forged galaxies has, on this small blue world, learned to rebuild limbs, to pause death, to sing across oceans, and to find its way home through forces unseen. The more we study these wonders, the clearer it becomes that nature's intelligence is not separate from our own. It is the source of it. To look at these creatures is to look into a mirror of possibilities, a reflection of the creativity that pervades all things. The world around us is not only alive, it is awake, humming softly with the same mystery that breathes through the stars. Humanity stands between earth and sky, a bridge between instinct and imagination. between the ancient pulse of the animal world and the infinite reach of the stars. For all our machines and cities, what truly defines us are not our tools, but our questions, our laughter, our songs, our stories, the strange and luminous ways we give meaning to existence. The mystery of being human is not something science can easily chart. It lives in language and love, in myths and memories, in the way our hearts recognize one another across time. We are, in every sense, the universe dreaming of itself, speaking in words shaped by breath and wonder. Language is perhaps our first and greatest invention, though it feels less like invention and more like discovery. No one knows exactly when or how it began. Long before writing, before cities, our ancestors were already shaping sound into meaning. Grunts becoming symbols, symbols becoming songs. Language allowed us to share ideas, to imagine together, to carry knowledge across generations. It turned thought into something communal, weaving individual minds into a single collective intelligence. But where did it come from? Some believe it began with gestures, hand signals that grew more complex until they leapt into voice. Others think it arose from music, rhythmic chants and calls that gradually gained structure and grammar. Archaeology offers only fragments, carved symbols, ancient bones marked with rhythm, hints of syntax embedded in art. The first word ever spoken left no trace, and yet it changed everything. With language, we learn not just to describe the world, but to reshape it. Words became bridges between minds, threads connecting inner and outer worlds. Every sentence spoken since then is part of that same lineage, an unbroken conversation stretching back to the first time a human dared to name the sky. And from language came laughter, one of the purest expressions of our shared humanity. We laugh long before we speak, and long after words fail us. It crosses all boundaries of culture and time. But why do we laugh? What strange joy moves the body to release sound in bursts of rhythm and air? Scientists think laughter began as a signal of safety, a way for early humans to show that danger had passed, that play, not fear, was at hand. In primates, laughter like panting appears during games of chase and mock fighting. Yet in us, it evolved into something deeper, a tool of bonding and release. We laugh in relief, in awkwardness, in sorrow, in awe. Sometimes laughter erupts when logic breaks down, when contradiction overwhelms reason and only joy can remain. It lowers stress, strengthens connection, and momentarily dissolves the boundary between self and others. A shared laugh is a small miracle, a synchronization of hearts, a reminder that even in absurdity, we are not alone. If laughter is humanity's heartbeat, then music is its breath. No one knows why organized sound can move us so profoundly. A melody can bring tears to our eyes. A rhythm can make our bodies move without thought. Across every culture and age, music appears, spontaneous, essential, transcending survival. Some scientists suggest that music evolved as a social glue, binding early communities through shared rhythm and song. Others think it began as courtship, a way to signal strength and sensitivity. Still others believe it is a byproduct of our brain's pattern-seeking nature, an accidental pleasure born from the mathematics of harmony. But such explanations miss the magic. Music reaches us at a level below words. It can make the heart ache without a story, summon memories we did not know we still carried, and give shape to feelings that cannot be spoken. In the vibration of strings, in the resonance of breath, we glimpse something universal, an emotional language older than speech, shared by every beating heart. And at the center of that symphony lies the greatest mystery of all: love. It binds parent to child, friend to friend, lover to lover. It drives our art, our faith, our wars, our healing. Biologists can trace its chemistry, the flood of oxytocin and dopamine that reward closeness and connection. evolutionary theory can explain its purpose: to keep pairs together long enough to nurture fragile offspring. Yet none of that captures what love feels like. The ache of longing, the peace of touch, the grief of loss. Love defies measurement. It is at once instinct and transcendence, a bridge between biology and meaning. It makes the ordinary sacred and the fleeting eternal. Perhaps love is the universe's way of keeping consciousness from collapsing into isolation. The force that ensures awareness seeks itself in another. Every civilization, every religion, every poem has tried to define it, yet love remains forever larger than definition. It is not something we possess. It is something that passes through us, reminding us that to live is to be connected, to be vulnerable, to care. From love come tears, another uniquely human mystery. Tears cleanse, but not just the body. They cleanse emotion. We cry not only from pain but from joy, not only from loss but from awe. No other creature weeps for reasons beyond physical distress. Why? One idea is that emotional tears evolved as a social signal, a silent cry for empathy, revealing our tear vulnerability and inviting comfort. Another is that they serve as release, lowering stress and restoring balance. Yet tears remain stubbornly enigmatic. They blur the line between biology and poetry, between survival and meaning. The same salt water that fills our eyes once filled the oceans where life began. To cry is to remember that we are water remembering itself, that even emotion has a lineage older than thought. In each tear glitters both the fragility and strength of being human. Humanity's emotions and expressions are mirrored in the stories we tell. Across continents and centuries, cultures that never met share the same myths. Tales of great floods, of tricksters, of journeys to the underworld, of sky gods and sacred fires. How can this be? Some believe these archetypes arise from shared experiences. The cycles of nature, the struggle for survival, the inevitability of death. Others, following Carl Jung, suggest that myths spring from the collective unconscious, patterns of thought hardwired into the human psyche. Whatever their origin, myths reveal a truth deeper than fact, that the human mind speaks in symbols, and those symbols echo everywhere. The serpent, the hero, the mother, the rebirth. These are not just stories, but mirrors of our inner lives. Even today, our films and novels retell the same ancient plots in new forms. Myths remind us that imagination is not escapism. It is ancestry. In every story ever told, humanity has been trying to remember itself. Among the most beautiful of our inherited instincts is cooperation, the ability to work together with strangers. Most animals limit altruism to kin and tribe, but humans reach beyond blood. We build communities, nations, even global networks of trust. Why? Evolution suggests that cooperation offered survival advantages. Groups that shared resources and protected one another thrived. But our generosity often goes beyond logic. We help those we may never see again. We donate to causes that will not benefit us directly. We risk ourselves for others. Children show empathy before they understand words, as if compassion is older than reasoning. Some researchers call this a moral instinct, a biological seed of kindness. Others think it stems from the mirror neurons in our brains, which let us feel the emotions of others as our own. Whatever its source, cooperation is the heartbeat of civilization. It is the quiet, invisible thread that holds humanity together. Proof that survival is not the highest goal of life. Belonging is. Yet civilization itself, for all its brilliance, carries a rhythm of rise and fall. Throughout history, great societies, the Maya, the Indus Valley, Mesopotamia, Rome, have flourished and then collapsed. Why do civilizations die? Some point to environmental change, war, or disease. Others see patterns in economics and power. Perhaps every society, like every living thing, has a life cycle, a time of growth, a time of excess, a time of decline. Civilizations rise on cooperation but falter when that bond erodes, when stories lose meaning, when empathy weakens, when the collective forgets its connection, the structure cracks. Yet from every collapse, new forms emerge. The ruins of one age fertilize the soil of another. The pattern is not of failure but renewal. Humanity's long heartbeat expanding and contracting across millennia. The lesson is humility. Progress is not a straight line, but a spiral, and every turning brings both light and shadow. Amid these cycles, one trait never fades: curiosity. It is the ember that has driven every invention, every voyage, every question ever asked. Why do we wonder? Other animals explore, but only humans seek knowledge beyond necessity. We are drawn to mysteries that have no practical use, compelled to ask why, even when no answer can help us survive. Some say curiosity evolved as a tool, an extension of problem solving, but it has grown into something more: a hunger for meaning, a spiritual instinct disguised as intellect. From the first spark of fire to the first satellite orbiting Earth, curiosity has been the soul's compass, guiding us toward the unknown. It is both gift and burden, the voice that will not let us rest. To be curious is to love existence enough to ask what it is made of, and to keep asking even when silence answers back. Perhaps curiosity leads inevitably to its twin, storytelling. Once we began to speak, we began to tell stories. Around fires, in caves, on temple walls, on glowing screens. We tell stories to remember, to teach, to heal, to dream. They are not just entertainment. They are the operating system of human consciousness. Through stories, we turn chaos into order, randomness into meaning. A life becomes a narrative. A culture becomes a myth. We live inside stories the way fish live in water, hardly noticing them until they change. Why do we need them so deeply? Because stories allow us to see ourselves reflected, to find purpose in pain and pattern in time. They remind us that we are part of something larger, that even in solitude we belong to the same tale. Every laugh, every tear, every word ever spoken becomes a thread in that vast human tapestry. And when we tell a story, we do not just describe the world, we help create it. So perhaps the mystery of humanity is not that we build machines or cross oceans, but that we keep trying to make sense of it all through language, laughter, music, love, and myth. We are creatures of meaning, haunted and blessed by awareness. We feel too much, remember too long, hope too fiercely, and that is our glory. From the first whisper of speech to the last song sung beneath the stars, we remain what we have always been, storytellers of the cosmos, seeking to turn existence into understanding and silence into song. The earth itself is a living mystery, not silent rock, but a restless, breathing world. Beneath our feet, mountains rise and crumble. Deep within, molten metal flows like the slow heartbeat of a vast organism. Around it, storms flash, seas whisper, and the air shimmers with unseen electricity. For all we have learned, our planet still holds secrets that science can only approach with awe. Strange lights, ancient cycles, and forces that shape life and death on cosmic scales. Among these mysteries, few are as haunting as ball lightning, a ghostly fire that drifts through the air like a living thought. For centuries, witnesses have described glowing orbs floating across fields, hovering in rooms, or gliding silently through storm clouds. Some vanish in an instant. Others linger, flickering orange or blue before exploding with a soft hiss. For a long time, scientists doubted they were real, dismissing them as illusions or the tricks of frightened eyes. But now, after rare recordings and credible reports, we know that something extraordinary happens in the charged air of certain storms. Theories abound. Perhaps they are plasma trapped by electromagnetic fields, or vaporized silicon glowing from the heat of a lightning strike. Some even suggest exotic reactions between charged particles and air molecules. Yet, no single explanation fits all accounts. Ball lightning defies the boundaries between matter and light, energy and form. A brief glimpse of the invisible forces that live within every storm. Similar lights have been seen in even stranger circumstances. During earthquakes, as the ground trembles, the sky sometimes answers with flickers of fire, streaks of blue or green, glowing clouds, silent bursts that dance above the fault lines. Known as earthquake lights, these ethereal flashes have been recorded for centuries, from ancient Japan to modern Italy. Only recently have scientists begun to confirm their existence through cameras and satellites. The cause remains uncertain. One idea suggests that immense pressure on rocks generates electrical charges that leap into the air, igniting molecules in sudden light. Another proposes that gases released from shifting crusts become ionized, glowing briefly before fading. Yet not every quake produces these lights, and their timing, sometimes before the tremors begin, makes them feel almost prophetic. They are the planet's own auroras, born of tension and release, reminders that even stone can sing when the world is under strain. Beneath those trembling crusts lies another power far older, the fury of volcanoes. Most eruptions are local dramas, fountains of fire, rivers of ash, the earth releasing pressure from within. But every so often, something far greater stirs. A supervolcano. When it erupts, the sky itself changes. Dust blots out sunlight, climates collapse, and species vanish. The eruption of Toba 74,000 years ago may have nearly ended humanity before it truly began. Why do some volcanoes remain ordinary, while others unleash destruction on a planetary scale? We know that pressure builds as magma rises, gases expand, and the crust weakens. Yet the precise trigger, the final tipping point between dormancy and cataclysm, is elusive. Perhaps subtle changes in temperature or chemistry push the system over the edge. Perhaps the crust fractures in ways we cannot yet see. Deep beneath Yellowstone, under Indonesia, under the Andes, vast chambers of magma wait in silence. Whether they will erupt again in centuries or millennia, no one can say. The Earth carries its own heartbeat of creation and destruction, and we are small enough to rest between its pulses. That same heartbeat drives the slow drift of continents, a phenomenon called plate tectonics. The surface of the Earth is not fixed but made of great slabs that slide, collide, and sink, giving rise to mountains, earthquakes, and oceans. This motion recycles the crust, stabilizes the climate, and shapes the very conditions for life. Yet for all its beauty, this process is unique. Mars and Venus, our planetary neighbors, show no signs of active tectonics. Their surfaces are locked and still. Why only Earth? Water may be the answer. It seeps into rocks, softening them, allowing the plates to move. Or perhaps it is Earth's internal heat, balanced just right between molten and solid. Some suggest a cataclysmic event long ago, a colossal impact that cracked the young planet's crust and set it drifting forever. Whatever the cause, plate tectonics is Earth's signature, a slow choreography of stone and fire that keeps the planet alive. From those shifting plates came the mountains and valleys that cradle rivers and oceans, yet the water itself remains a riddle. Where did it come from? When the Earth was new, its surface was molten, too hot for liquid water to exist. Some believe it arrived later, carried by icy comets and asteroids that bombarded the planet, leaving behind oceans as they melted. Others argue that water was here from the beginning, trapped deep in the mantle and slowly released by volcanic breath. Is our water alien or native? The chemical fingerprints are mixed, some matching comets, others matching Earth's own rocks. Perhaps it is both, part gift from the stars, part inheritance from within. Whatever its origin, water is the planet's miracle, the element that turned dust into life. Every drop that falls, every wave that breaks, carries the memory of the cosmos. High above those oceans hangs the moon, our ancient companion, always showing us the same face. For millennia, we assumed both sides were alike, until spacecraft revealed a surprise. The near side, the one we see, is smooth and dark with vast plains of frozen lava. The far side is rugged, mountainous, almost entirely without those dark seas. Why should the two faces of the same body be so different? One theory suggests that the young Earth's heat once bathed the near side, melting it while the far side cooled more quickly. Another points to a great collision, a smaller moon merging with the larger one, reshaping one hemisphere but not the other. Perhaps even the moon's orbit and internal dynamics created uneven crusts and volcanic flows. No theory fits perfectly. And so the far side remains a mystery, a scarred, silent witness to the early violence of our solar system. Beneath our own feet lies another enigma: the Earth's core. More than 3,000 kilometers below the surface, it is a sphere of molten iron and nickel swirling around a solid inner heart. This motion generates the magnetic field that shields us from solar wind, without which our atmosphere would erode and our planet would die. Yet we cannot see or touch it. We infer its presence from seismic waves and magnetic shifts, from mathematics and imagination. Why does it behave the way it does? Why does its strength vary? Sometimes weakening, sometimes reversing entirely. The outer core flows like a liquid ocean, but the patterns of its movement are unpredictable. The field it creates flickers, wobbles, and occasionally flips. Over millions of years, Earth's magnetic poles have reversed many times, north becoming south and south becoming north. These magnetic reversals are written in ancient rocks, in bands of iron frozen at the ocean floor. But what triggers them remains uncertain. Perhaps turbulence deep within the molten core destabilizes the field. Perhaps it is part of a natural cycle we do not yet understand. During reversals, the field weakens, exposing the planet to cosmic radiation. Yet life has survived each one. The compass of Earth spins, but the rhythm of life endures. While the inner Earth turns in silence, its surface dances with ice and fire, the long rhythm of ice ages. Every 100,000 years or so, glaciers surge across continents, then retreat. The pattern is recorded in ocean sediments and frozen air trapped in ancient ice. Scientists believe these cycles are driven by subtle changes in Earth's orbit and tilt, the Milankovitch cycles, which alter how sunlight warms the planet. But those orbital rhythms alone cannot explain everything. Volcanic eruptions, ocean currents, and greenhouse gases all play their parts in a vast symphony of feedback. Sometimes small changes in temperature cascade into great transformations. The last ice age sculpted the landscapes we know, carving valleys, shaping lakes, spreading fertile soil. And within its retreat, civilization was born. The mystery is not only why the ice comes and goes, but how delicately balanced our world remains, poised between freeze and fire. Through all these cycles of renewal and destruction, life has persisted, but not without loss. At least 5 times in Earth's history, catastrophe has swept across the planet, erasing most of what lived. These mass extinctions mark the punctuation of evolution, the moments when the story nearly ended. The most famous came 66 million years ago, when an asteroid struck the Yucatan Peninsula, ending the age of dinosaurs and paving the way for mammals. But greater extinctions came before. The Great Dying, 250 million years ago, wiped out 90% of species. Each time, the causes intertwine. Asteroid impacts, supervolcanoes, shifting continents, collapsing climates. Sometimes multiple disasters struck at once, amplifying each other until ecosystems unraveled. Yet, from every extinction, life returned, transformed. The forests regrew, the oceans filled again, new forms emerged from the ashes of the old. Extinction is not merely death, it is renewal on a cosmic scale. The Earth shedding one skin for another. Still, the lesson is sobering. Stability is an illusion. The same forces that gave us life can take it away. Standing upon this fragile planet, we are both witnesses and participants in its unfolding story. Ball lightning, earthquake lights, shifting poles, rising mountains. These are not random curiosities, but verses in a single poem written by Earth's restless heart. We are children of that poetry, formed from its elements, sustained by its rhythms. The ground beneath us is not solid but alive, forever changing. The sky above is not empty but electric, humming with energy. Even the calmest moment carries the memory of ancient storms. Perhaps that is the greatest truth hidden in all these mysteries. That the Earth is not a stage for life, but part of the performance itself. Every tremor, every breeze, every flash of light is a gesture in a vast and ongoing dance. To live here is to be part of that movement, to feel the planet breathing beneath our feet, to hear its heartbeat in the wind and the tide. The Earth's mysteries are not meant to frighten us, but to remind us of belonging. We do not stand above the world, we rise within it, as one brief note in its endless song. And though our understanding grows, the wonder remains. The knowledge that this planet, our home, still keeps secrets as deep and beautiful as the stars. In the vast family of worlds that circle our sun, each planet and moon tells a different story. A story of motion, of violence, of ice and fire, of mystery written into light. The solar system is not static, it is a grand choreography, a living archive of creation where every orbit whispers of beginnings we barely comprehend. Even after centuries of observation, so much remains unsolved. Strange tilts, endless storms, oceans beneath ice, and traces of water long vanished. Our neighboring worlds hold questions as haunting and beautiful as any in the cosmos. Among them, Saturn reigns as a world of elegance. Encircled by the most breathtaking structure in the solar system, its rings. From a distance, they appear as solid, luminous bands. Up close, they are billions of icy fragments, orbiting in perfect, delicate balance. Each no larger than a house, a snowball, or a grain of sand. For centuries, astronomers assumed the rings were as old as the planet itself, relics from its birth more than 4 billion years ago. But recent evidence tells a different story. The ice of the rings is almost pure white, too clean to have endured billions of years of cosmic dust. Data from the Cassini spacecraft suggests they may be astonishingly young, perhaps only a few 100 million years old, a blink in planetary time. If so, they could have formed from the destruction of a moon torn apart by Saturn's gravity, or from a passing comet that wandered too close and was shredded into countless particles. The mystery deepens when we realize they are fading. Saturn's gravity slowly pulls the icy grains inward, like a slow rain of light falling into darkness. We are living in the brief era when Saturn wears this radiant crown, a beauty both ancient and ephemeral. Farther out, Uranus drifts in quiet strangeness, a planet unlike any other. Its pale blue clouds roll not upright, but sideways. Its axis lies almost flat, tilted by 98 degrees, so it spins like a ball rolling through its orbit. One pole stares directly at the sun for decades, while the other endures endless night. How did it come to be so strangely oriented? The leading theory imagines a colossal collision, a protoplanet the size of Earth striking Uranus long ago, knocking it onto its side and perhaps stripping away part of its atmosphere. But that impact should have left scars or a massive moon, and we find neither. Others suggest that gravitational tugs from neighboring giants, Jupiter or Saturn, once destabilized its orbit, or that the planet's internal dynamics shifted slowly, twisting its axis over eons. Whatever the truth, Uranus spins in serene defiance of expectation, a reminder that even the solar system's symmetry can be broken by chance. Its strange posture gives it bizarre seasons. Half a century of light, half a century of shadow. In that twilight world, time itself seems to turn sideways. Nearby, Venus offers another paradox. Nearly the same size and composition as Earth, it might have been our twin, but instead, it became our mirror of extremes. Its clouds are thick with sulfuric acid, its atmosphere a crushing ocean of carbon dioxide, its surface hot enough to melt lead, and its rotation runs backward. On Venus, the sun rises in the west and sets in the east. One day lasts longer than an entire Venusian year. Why? Some believe a giant impact early in its history reversed its spin, flipping the planet like a coin. Others suggest a slower transformation. The thick atmosphere and internal tides gradually dragging the planet backward through friction. Whatever the cause, Venus is a world turned inside out, familiar yet alien. Earth's reflection, warped by heat and time. Beneath its shrouded sky lies a secret history, a cautionary tale of what happens when a planet's balance is lost. Beyond Venus, on the outer edge of the solar system, Neptune roars with winds faster than any on Earth, storms that reach 2,000 kilometers an hour, swirling through a deep blue atmosphere colder than ice. The most famous of these tempests, the Great Dark Spot, was first seen by Voyager 2 inches 1,989. A massive vortex the size of our planet. But when the Hubble telescope looked again years later, it had vanished, dissolved into the clouds, only for new dark spots to appear elsewhere. Why does Neptune, so far from the sun, so frozen, harbor such violence? With so little sunlight, its storms should be weak. Yet the planet's internal heat, still radiating from its ancient formation, fuels chaos from below. Layers of methane and hydrogen convect endlessly, creating temporary eyes of fury that come and go without warning. Each storm is a heartbeat in the planet's unseen rhythm, an echo of a world alive with invisible fire. If Neptune's storms are transient, Jupiter's Great Red Spot is the opposite, a storm so ancient it has outlived empires. For at least 3.5 centuries, it has raged across the planet's southern hemisphere, a swirling cyclone of crimson clouds larger than Earth itself. Driven by Jupiter's immense atmosphere, it rotates counterclockwise, fueled by energies we cannot yet fully model. Yet it, too, is changing. In recent decades, the Great Red Spot has been shrinking, its once enormous oval now only half its former width. Some astronomers fear it may fade away entirely within a century. Others believe it will renew itself as storms merge and feed its power. Why did it form? Why has it endured? And why does it bleed red light into Jupiter's golden clouds? We do not know. It remains one of the grandest mysteries in our skies. A monument of motion that reminds us that even in apparent stability, change is constant. Far beyond these giants, at the edge of the sun's dominion, lies the Oort cloud, a vast, invisible halo of icy bodies surrounding the solar system like a ghostly shell. No telescope has ever seen it directly. Its existence is known only through the comets that occasionally fall inward, flashing their tails across our skies. These comets are wanderers, born in the Oort cloud's frozen wilderness, billions of kilometers away. Some were thrown there long ago by the gravitational chaos of the young planets. Others may have drifted in from neighboring stars, captured by the sun's pull. It stretches so far that its outer edge may blend into interstellar space, the threshold between our system and the galaxy beyond. The Oort cloud is our cosmic attic, storing the leftover materials of creation, the frozen memory of the solar system's birth. Every comet that visits the inner planets is a message from that distant frontier, a whisper from the dawn of time. Closer to home, the moons of the outer planets hide oceans beneath their icy crusts. Europa, Enceladus, Titan, these are worlds that defy our old definitions of habitability. On Europa, one of Jupiter's moons. The surface is a cracked mosaic of ice. Beneath it, scientists believe, lies a vast ocean, perhaps twice the volume of all Earth's seas combined. The heat from tidal forces, as Jupiter's gravity flexes the moon's core, keeps the water liquid. Where there is water, there may be life. Similarly, Enceladus, a small moon of Saturn, astonishes us with its beauty and defiance. At its south pole, giant fissures called tiger stripes spew jets of vapor and ice into space, plumes that shine like fountains against the dark. The Cassini spacecraft flew through them and found salts, organics, and traces of complex chemistry. These geysers may connect to a global ocean beneath the surface, warmed by hydrothermal vents on the seafloor. Conditions not unlike those that may have birthed life on Earth. If something swims in that hidden sea, it would be our closest kin in the cosmos. Then there is Titan, Saturn's largest moon, a world eerily familiar, yet profoundly alien. Its orange atmosphere hides lakes, rivers, and seas, not of water, but of liquid methane and ethane. Rain falls, rivers flow, waves lap upon hydrocarbon shores. Yet there is a mystery in Titan's cycle. Methane in the atmosphere should have long vanished, destroyed by sunlight over geological timescales. Something replenishes it, perhaps cryovolcanoes, erupting cold plumes of gas from deep below. Perhaps chemical reactions in its crust, or perhaps processes we cannot yet imagine. Some even speculate that Titan's methane might have biological origins, a sign of life based on chemistry entirely unlike our own. Whatever sustains that balance, it makes Titan a mirror of Earth's water cycle, a reflection written in alien elements. There, under its orange haze, lies a version of our own planet, rewritten in another language. And then there is Mars, the planet that calls to us more than any other. Its deserts are cold and red, but its surface bears the scars of rivers, lakes, and oceans. Long ago, water flowed freely there, carving valleys, pooling in craters, leaving behind minerals that could only form in liquid. What happened to it all? Some of it remains frozen beneath the surface or locked in the polar ice caps. Some escaped into space when Mars lost its magnetic field, stripped away by solar wind. The rest may lie hidden underground, in aquifers deep below. Why did Mars change while Earth thrived? Its smaller size meant it cooled faster, its core solidified, and its protective magnetosphere faded. Without that shield, the atmosphere thinned and the water fled. Yet even now, we find tantalizing hints, recurring streaks that might mark briny flows, traces of ancient river deltas, signs of methane that appear and vanish with the seasons. Perhaps Mars still breathes faintly beneath its dust, holding the last remnants of its once blue heart. All these mysteries, the rings of Saturn, the tilt of Uranus, the backward spin of Venus, the storms of Neptune and Jupiter, the hidden oceans of icy moons, remind us that the solar system is not a clockwork of perfection, but a living family of anomalies. Each world is a chapter in the same story. How chaos becomes beauty, how chance becomes order, how time sculpts wonder. We study these planets not only to understand them, but to understand ourselves. For in their diversity, we see reflections of what Earth might have been and what it could one day become. The farther we travel, the more we realize how little we know. The space between worlds is vast, but so too is the space within our ignorance, a silence that invites curiosity, not despair. Every discovery widens the mystery. Every answer is a doorway to more questions. Perhaps that is the true gift of the solar system, that it refuses to be conquered by comprehension. It remains alive, restless, turning, each world carrying a secret it will reveal only when we are ready to listen. The sun holds them all in its invisible embrace. Saturn's delicate rings, Uranus's tilted spin, the storms of Neptune, the echoing moons, bound not by certainty, but by rhythm. We, the observers, float within that rhythm too. As we gaze outward into space, we are really gazing backward in time, into the history of our own origins. The dust that became Earth, the ice that became oceans, the fire that became life. All were born from this same celestial family. The solar system is not merely our neighborhood, it is our ancestry, written across the sky. And somewhere in that vastness, in a plume of ice on Enceladus, in a hidden ocean beneath Europa, in a fossilized delta on Mars, there may be another beginning waiting to be found, a second spark, a second song. Perhaps the solar system is not finished with its miracles. Perhaps it is still creating, still dreaming, still whispering to the small blue world that listens. Beneath all the stars and particles, beneath every breath and beam of light, lies something quieter and more mysterious. The order of reality itself. The universe moves with a precision that borders on poetry. Galaxies spin, atoms hum, waves rise and fall according to laws so exact that we can describe them in symbols drawn on a page. Yet the deeper we look, the stranger the symmetry becomes. Why does the universe follow rules at all? And why are those rules written in the language of mathematics? For centuries, humans have used numbers to measure and predict, to build and explain. But somewhere along the way, we realized something extraordinary. The equations we invented in our minds perfectly describe the behavior of the cosmos. Einstein's relativity, scribbled in symbols, predicts the bending of light near stars. Maxwell's equations, born in thought, capture the shimmer of radio waves. The mathematics existed before the proof, as if we were discovering, not inventing, a truth that had always been there. Why should abstract numbers align so uncannily with physical reality? Some say mathematics is the universe's own code, an eternal structure woven into existence itself. Others believe it reflects the architecture of the human mind, shaped by evolution to perceive patterns. Perhaps the harmony between thought and cosmos is no coincidence. Perhaps we are made of the same order we seek to describe. The universe may not speak mathematics, but it seems to think in it. Within that mathematical order are constants, the fixed numbers that define the strength of gravity, the speed of light, the charge of the electron, the ratios that hold atoms and stars together. If any of these values were even slightly different, the universe would collapse or remain barren of life. This puzzle, known as the fine-tuning of the constants, raises profound questions. Why these values and not others? Are they chosen by chance? Or do they emerge from a deeper principle still hidden from us? Some imagine a multiverse where countless realities exist, each with different constants, and we live in the rare one where life can exist. Others search for a single underlying equation that would make all these numbers inevitable, as natural as the notes in a perfect chord. But until we find that foundation, the constants remain silent sentinels. Clues that the universe might not be accidental, but exquisitely intentional in its design. Even in a world so precisely ordered, randomness seems to thrive. Flip a coin, shuffle cards, watch radioactive atoms decay. Unpredictability surrounds us. But does true randomness exist? Or is it merely the reflection of complexity we cannot see? In classical physics, nothing is truly random. Every motion follows from what came before. Yet, in the quantum world, chance rules absolutely. An electron might appear here or there, and no equation can predict where, only the probability of its being. Einstein resisted this, insisting God does not play dice with the universe, but experiments suggest otherwise. Quantum mechanics is fundamentally uncertain. Still, some physicists believe hidden laws may underlie this chaos, guiding it in ways we have yet to perceive. Others propose that randomness is not ignorance but a feature of creation, a necessary breath of freedom within the clockwork. Perhaps order and chance are not opposites but partners, shaping a universe that is both stable and alive. No concept ties all these mysteries together more deeply than time. It is the current in which all things drift, the silent measure of change. Yet its nature defies comprehension. We feel time flow from past to future, carrying us like a river. But physics tells us its laws are symmetrical. They work equally well backward or forward. Why then does time move only one way? Entropy offers one answer. The universe began in an improbably ordered state, and ever since, disorder has increased, giving time its direction. But this only shifts the question backward. Why did the universe begin in order at all? Others think time itself may be an illusion, a trick of perception born from how consciousness arranges events. In relativity, time bends and stretches with speed and gravity. In quantum theory, it sometimes disappears altogether. Perhaps time is not a line, but a landscape, and what we call now is only the point our awareness wanders through. To exist, then, may be less about moving through time than about being time, moment by moment, memory by memory. The flow of time carries another enigma, the victory of matter over antimatter. When the universe began, physics predicts that both should have been created in equal amounts, and when they meet, they annihilate, leaving nothing but light. If they were truly equal, there should be no stars, no planets, no us. And yet, somehow, matter won. For every billion particles of antimatter, there were 1,000,000,001 of matter. And that single surplus built everything we know. Why? Experiments reveal tiny asymmetries in how particles behave, but not enough to explain the imbalance. Somewhere, in the physics of the early cosmos, a small imperfection tilted the scales, allowing creation to survive annihilation. The fact that anything exists at all is a triumph of this cosmic bias, a quiet rebellion against nothingness. Even the substance of existence, mass itself, hides a secret. For centuries, we knew that matter resists motion, that things have weight, but not why. In 2012, the discovery of the Higgs boson confirmed what theory had long predicted. An invisible field fills the universe, and as particles move through it, they gain mass, like swimmers feeling the drag of water. This Higgs field is the invisible ocean in which reality swims. Yet its origin is still unknown. Why does it have the strength it does? Why do different particles interact with it in different ways? The Higgs answered one question but opened many others, revealing that even solidity is born of emptiness. Everything that feels firm, your body, the planet, the stars, is, at its core, the vibration of invisible fields. But is space itself smooth or grainy? At human scales, reality feels continuous. Lines can be divided forever. Moments can be sliced infinitely thin. Yet quantum theory hints at a smallest possible unit, a pixel of reality, beyond which division loses meaning. This is the idea of quantized space, where space-time itself is made of discrete building blocks, loops, networks, or quanta of geometry. If true, the universe is not a fluid but a tapestry, woven from threads so fine we cannot yet perceive them. The smallest possible length, the Planck length, is about 10 to the minus 35 meters, a distance so tiny that comparing it to an atom is like comparing an atom to the sunday. At that scale, space may boil with uncertainty, flickering between existence and nothingness. No experiment can yet reach it, but it sets the boundary between what is knowable and what lies beyond, the place where the map of physics ends and mystery begins. All of this leads to one final question, perhaps the deepest of all. Why are the laws of physics what they are, and not something else? Why gravity and electromagnetism, not some other set of rules entirely? Some say there could be no other way, that these laws are self-consistent, inevitable. Others believe they are just one expression among infinite possibilities, chosen by chance or by conditions we cannot perceive. The why of the laws may forever remain beyond our reach. We can describe how they work, but not why they exist. Yet perhaps that is enough. To ask the question is already to participate in the answer, for curiosity is itself a product of those same laws, the universe wondering about its own rules through us. And so we reach the edge of knowledge, the horizon where human understanding fades into the unknown. Every breakthrough brings new paradoxes. Every solution reveals deeper questions. Can we ever truly understand everything? Perhaps not. The mind that seeks to grasp the universe is itself part of that universe. A wave trying to measure the ocean from within. There may be truths beyond logic, dimensions beyond comprehension, but the act of seeking is what makes us alive. To explore is to honor the mystery, not to erase it. Maybe the purpose of knowledge is not completion but communion. To see the pattern and feel awe. To recognize that reason and wonder are not enemies, but allies. The universe does not need us to solve it. It needs us to listen. Somewhere between the precision of mathematics and the silence of mystery lies what it means to be human. Creatures made of atoms, ruled by laws, yet capable of love, art, and curiosity. Perhaps understanding everything is impossible, but understanding that we are part of it, that the laws of reality flow through our very breath, is enough. And in that realization, we come full circle, from the cosmic to the personal, from the equations that shape the galaxies to the heartbeat that shapes a thought. The universe is both infinite and intimate, mathematical and miraculous. It does not end at the edges of what we know. It begins there. Each unanswered question is not a barrier, but an open door, inviting us to step into wonder once more. The universe, in all its vastness, has never stopped asking questions, and neither have we. Every mystery we have explored, from the smallest atom to the farthest star, is not an end, but a beginning. Not a wall, but a doorway. Each unanswered question is a quiet invitation to wonder, to lean forward, to listen, to imagine. The beauty of science is not that it knows everything, but that it dares to admit what it does not. Knowledge is not a static light. It is a flame that flickers brighter only when surrounded by darkness. What keeps it alive is not certainty, but curiosity. For as long as we have existed, we have looked up and asked why. And in every age, our questions have carried us closer. Not always to answers, but to awe. Science is not the absence of mystery. It is the language through which we speak to it. Each discovery hums with new uncertainty. Each explanation opens another horizon. The unknown is not an enemy to be conquered, but a companion that keeps us humble, awake, and alive. Without mystery, there would be no wonder. Without wonder, there would be no search. The universe dreams through us, through our curiosity, our imagination, our need to understand. So tonight, as you drift towards sleep, let these questions remain. The origins of life, the song of time, the dance of galaxies, the quiet heartbeat of thought itself. Let them hover around you like distant constellations, too far to reach, yet bright enough to guide you. You do not need to solve them now. Let them become the stars above your inner night, each one a reminder that not knowing is its own kind of peace. The mysteries are not here to trouble you, but to soothe you, to remind you that you are part of something vast, unfolding, and eternal. You are the universe remembering itself for a brief and beautiful moment through human eyes. Every breath, every dream, every act of wonder is the cosmos continuing its story. So rest now. Let the questions drift through you like starlight through water. There is nothing to chase, nothing to prove, only the gentle certainty that mystery itself is the lullaby of existence, the soft music that rocks human curiosity to sleep. And as you close your eyes, imagine the stars turning slowly above. the earth breathing beneath, the whole of creation whispering in its quiet language. No answers are needed tonight. Only wonder. Good night, traveler of thought. May your dreams carry you farther still, into the spaces between questions, where the universe waits, patient and infinite, for your return.